In section 43, we will simplify expressions. The use of the calculator is allowed for this section. A rational expression is an expression whose numerator and denominator is a polynomial. When we're given a rational expression, our goal is going to be to simplify that. So in each case, we're going to take the numerator and denominator and we're going to factor each. In the numerator here, we can see that we can GCF a 3, and that's going to give us 3 times the quantity x plus 3. In the denominator, this is the difference of two squares. So I'll get an x plus 3 and x minus 3 as my two different factors here. Now from there, I'm looking at simplifying it one more time. As I simplify it further, I do see that these would cancel, and that's why my final expression is 3 over x minus 3. Now, when I'm talking about excluded values here, what we want to keep in mind is that the denominator can never be 0. So we're actually going to look at this step right here, where I had two parts, two different factors in my denominator. If I set each of those factors equal to 0, when I set x plus 3 equal to 0, or say that it can't equal 0, I find out that x cannot equal negative 3. When I say that x minus 3 cannot equal 0, I would get that x cannot equal 3. So these are my excluded values here. Now in the next part, we want to identify these excluded values as a whole or a vertical asymptote. Because we're eliminating the x plus 3's in this case, the part that's canceled is going to create a hole in the graph. And that hole is going to be at its corresponding value. So when I said that those could not be equal to 0 and our result was negative 3, that's why we're going to have a hole at negative 3. Now, what's left in the denominator once the expression is fully simplified, and in this case that's the green part, this x minus 3, we found out that that meant that x could not equal 3. That was my excluded value that came from the denominator. And that is going to tell me that that's going to be a vertical asymptote here. So again, the cancel term is going to give us the whole, and the denominator is going to give us the vertical asymptote. And this is the graph of this rational expression, and we will look at that in Unit 8. So taking a look at this next one, again, the first step is for us to factor both the numerator and denominator. So go ahead and try to factor the numerator and denominator. Now as we factor that, we can GCF of 4x in the numerator, and we're left with 4x times the quantity x plus 2. In the denominator, I can take a GCF of 12 out, and that gives me 12 times the quantity x plus 2. From there, the x plus 2's can cancel, and also 4 divided by 12 can reduce to 1/3. So our answer ends up being 1x, or just x, divided by 3. Now when I'm looking for the excluded value here, again, I want to go to this step right here and setting any of my factors not equal to 0. So if I try to do that with 12, there's no variable to look at here, so I don't need to worry about 12. But where I see x plus 2, if I say that cannot equal 0, that would give me a value of negative 2 as an excluded value. Then I'm going to want to classify that as a whole or a vertical asymptote. And because that came from the cancel term, that's going to be the whole. Other than that, I don't have anything else if I'm looking at the denominator here that has an x. So that means that we're not going to have a vertical asymptote in this case because I'm not left with an x in the denominator. So there's no way for us to turn this into a 0. We'll take a look at the next example. So again, try to factor that, simplify, and come up with the excluded values. Also classify them as a whole or a vertical asymptote. And with this one, when I factor x squared plus 4x plus 4, we get x plus 2 twice as our factors. Or you could write that as x plus 2 in parentheses with the squared on the outside. If I factor this, this is difference of two squares. I'm going to get x minus 4 and x plus 4. Now in this case, nothing is going to cancel here. I don't have any matching factors top and bottom. So this is actually fully simplified. When it says to identify the excluded values, again, when we're looking at excluded values, we are only paying attention to the denominator. So if I say that x minus 4 cannot equal 0, it's going to tell me that 4 is going to be one of our excluded values. Same thing over here. If I say that that cannot equal 0, that's going to give me negative 4. So my two excluded values are 4 and negative 4. Now we would get a whole if that came from a canceled term. Because I didn't cancel either of those factors, that means that they're both going to be vertical asymptotes. And again, that's at -4 and at +4. Now here are a few examples of problems that reduce down to -1. So we want to take a look at the original setup here. We can see if we look at this originally, x minus 1 and 1 minus x, they're not the exact same thing. And that's because here the x is positive and it's negative here. The 1 is negative here and it's positive here. So if we need to switch both of the signs here, what we can do is GCF out a negative. And what that's going to do, we'll have the negative on the outside, is it's going to switch both of those. Now technically, if you left this as -1 plus x, that would be okay. And -1 plus x is the same thing as x minus 1. It's best if we write them this way. It's a little bit more clear that we can cancel those. And when I cancel that, I'm technically left with 1 divided by -1, which is -1. We can do the same thing over here. Again, I GCF a negative out. I'll be able to cancel 3x minus 4 then. And again, it's 1 divided by -1, which is -1. And then for this last example, in this case, we took it out of the numerator. So if I'm GCFing that negative out, I'm left with, again, you could write it as x minus 5, but if you wrote it as -5 plus x, that's also fine. Those parts would cancel, and I'm going to be left with -1 over 1, which is -1. And in each of these cases, you could have taken the negative out of either the numerator or the denominator. So there's not a correct one to take that out of. Now we're going to take a look at these expressions, and we want to see which ones are going to simplify to -1. As I'm looking at A, because my 6 is positive here and negative here, the x is negative here and positive here, if I GCF to negative out, if either the top or the bottom, I would be able to cancel a factor, and my answer is going to be -1. So this one's going to simplify to -1. Looking at B, I have a +4 and I have a -4, but my x's are the same. So I don't want to change both signs in order to have this cancel, and you're not able to just change one of the signs. So B is not going to work. The same thing happens for C. Again, these match, but these don't, and it's only going to reduce down to -1 if both need to be changed in either the numerator or denominator. For D, I've got x minus 5, so x is opposite top and bottom, but I have a -5 here and a +4 here. Those aren't even the same number, so this one's not going to work. For this one, I actually have the exact same thing, top and bottom, on E. So 2x plus 3 is equivalent to 3 plus 2x, so that would be reducing to 1. And then for F, if I'm looking at this, I've got a +1 here and a -1 here, a -5x here and a +5x here. So this is another situation where, since we want both of the top or both of the bottom ones to change, I could GCF a -1 and cancel from there. So my answer to this is going to be A and F. So we'll take a look at this example here. Again, we want to start by factoring and seeing what our excluded value or values will be. Now when we factor this one, in the numerator, I'm going to be able to factor this to 2x minus 1 times the quantity x plus 3. And then I've left this alone. Now, what I'm hoping to have happen here is that something cancels. And as I compare these two factors, I do see that if I GCF to negative out of one of those, I would be able to cancel that set. So that means that since this part is going to cancel and become a -1, I'm left with -1 times the quantity x plus 3, which I could then distribute that -1 in. That would give me -x minus 3. As far as the excluded values here, what I would be doing is setting 1 minus 2x not equal to 0. That would require me to subtract 1 and divide by -2, so I'm going to end up getting 1/2 for that. That will be my excluded value. And that's going to be the only excluded value on this because I don't have anything else with a variable in the denominator. The reason that this is classified as a whole is that it comes from the canceled term. So now I'll spend a couple minutes on the next problem. Now in the numerator, I can GCF a 5. I'm left with 5 times the quantity x plus 5. In the denominator, it's difference of 2 squares. So that's going to be x plus 5 and x minus 5. Now my excluded values, again, I want to set both of these where they're not equal to 0. So this one's going to give me -5 and this one's going to give me +5. Those will be my excluded values. From here, I want to think about the canceled term is going to give the whole. So that's going to be a whole at -5, and then the vertical asymptote is coming from what's still left in your denominator once it's fully simplified. That's this one, which gave us a 5. Therefore, we end up with a whole at -5, and we end up with a vertical asymptote at +5. Spend a few minutes on this one. And here I've got the numerator saying as x minus 3. The denominator is going to be the quantity x minus 3 times the quantity x plus 6. From there, my excluded values, I set both of these where they're not equal to 0. It's going to give me 3 and -6. Those are my two excluded values. Once again, the whole is going to come from the canceled term. So since I'm canceling the x minus 3's, it's going to be a whole at 3. And then the vertical asymptote is going to come from what's still in the denominator, and that's going to be a vertical asymptote at -6. Try this one. And on this one, again, we can look at x squared minus 16, and we can factor that to x plus 4 and x minus 4. Now, once again, we see that this does not match perfectly with either of these. But I do want to notice that if I changed both of these signs here, it would match up with this one. So these are going to cancel and give us a -1, and that -1's in the numerator. Technically, you could put it in either the top or the bottom, but it's going to make more sense to put that in the numerator since I need something to hold that place anyway. This x plus 4, it didn't cancel. It needs to stay in the denominator. Now, as far as our excluded values, if I set this not equal to 0, I'd get -4. This one would give me +4. Those are my two excluded values. The one that comes from the canceled term is this one, and that gave us 4. So it's going to be a whole at 4 and a vertical asymptote at -4. Try this one. And for this one in the numerator, when I factor this, I get x plus 4 and x plus 1. In the denominator, I'm going to get x plus 5 and x plus 4. Now from here, I do want to look at my excluded values. Again, if I say that this cannot equal 0 and this cannot equal 0, I'm going to get -5 and -4. Those are my excluded values. The x plus 4 is the canceled term, so I'm going to get a whole at -4. Then, since x plus 5 is still in my final answer, it's going to be a vertical asymptote at -5. It's what would make our denominator a 0 there. Now there's a couple of steps here. First of all, in the numerator, I can GCF an x. Once I GCF that x out, I'm left with x squared minus x minus 42. Same thing in the bottom. This one I can GCF a 2. Once I take out 2, I'm left with this. From here, I want to see if I can factor further. So when I try to factor that further, the top here is going to end up giving me x minus 7 and x plus 6. In the denominator, if I factor this, I get x minus 7 and x minus 3. So here, I will be able to state my excluded values. If I set 2 not equal to 0, there'd be no variable to solve for. So I'm not going to do anything with 2. If I set x minus 7 not equal to 0, I'm going to add 7 over, and we find out that 7 is an excluded value. This one then is going to give me 3. Now the canceled part is going to be this part, the x minus 7's. That means I'm going to have a whole at 7, and then because x minus 3 is still in the denominator here, it's going to be a vertical asymptote at +3. Try this one. Once again, we want to start by looking for a GCF here. In the numerator, I can take out a 3, and this is what I'm left with. The denominator doesn't have any GCF, so we left that as is. From there, we'll factor. Once I have my factors here, again, I'm going to say neither of these can equal 0. This one's going to give me 10. This one's going to give me -7. So those are my excluded values. It's going to be a whole at 10 because that's the canceled part. And then since I'm still going to have x plus 7 in the denominator, it's going to be a vertical asymptote at -7. Try this one. And here in the numerator, my factors ended up being x minus 7 and x plus 2. In the denominator, I got x minus 8 and x plus 2. Excluded value, again, we only look at the denominator. I'm going to get 8 and -2 as the excluded. The whole comes from the cancel term. So once I cancel x plus 2, that's going to give me a whole at -2. Vertical asymptote comes from the denominator. So if I set that not equal to 0, I get 8, and that's going to be my vertical asymptote. Try this one. And once again, we want to look for a GCF. In the numerator, there isn't a GCF, but in the denominator, there is. So in the numerator, we're going to factor this out, and we get 2x minus 3 times the quantity x plus 6. In the denominator, I can GCF 2x out, and then I'm left with 2x minus 3. So when I'm looking for the excluded values, again, I set 2x not equal to 0. If I try to solve that, I'm dividing both sides by 2. I'm still going to say that 0 then is my excluded value. Over here, if I set that not equal to 0, I would add 3 and divide by 2. That gives me x is not equal to 3 over 2. So those are going to be my excluded values at 0 and at 3/2. Then as I'm looking for whole versus vertical asymptote, the 2x minus 3 part was the part that canceled. So that's going to be the whole at 3/2. The vertical asymptote is going to come from what we have in the denominator here. That's going to be at 0. And that brings us to the end of this lesson. You can go ahead and complete the exit slip associated with this lesson, and your homework is in practice at 43.